Hello and welcome to my channel. Today we are going to discuss about the input, processing and output which is performed in the objects. Now this very common topic and very common thing that all of us already know, that the processing work that is performed in all the objects involved three stages: input, processing and output. And the fact is that this input, processing and output takes place in all the objects in the world, whether it is living, whether it is non-living. All the objects are performing three tasks, or they work based on the principle of IPO, that is input, processing and output. Now let's see, for example, any object that take an example of any object that we see around us. These objects, they don't respond until unless the message is given to them. And how they take the message, how they take the input. The objects, the real world object, they take input through eyes. They see, and the vision, the picture, the video that they see is the input for them, and they respond according to the things what they see. The second kind of input is they listen sound. They listen through the ear. So for them, eyes, ears, tongue, nose, and skin. All the five senses are the medium of receiving inputs. They see, and the sight, the vision takes the input in the form of pictures and video. Listen, they listen to the sound, and that goes as the sound input to their brain. They taste, they like it, not like it, bitter, sour, salty. All these tastes are also checked by the input device that is called tongue. So it goes on the tongue, and tongue will receive it and then find out, the memory will decide what kind of taste it is. Then sense of smell, nose, and the sense of touch, hard, soft, rough, smooth, slippery. Now all these are five senses are the basic input devices or basic input units of the living objects, and they are giving idea. The similar functioning devices have been developed in the field of computer, like webcam is for seeing, same as eyes, listening, microphone, and tongue and nose. For the purpose of the tongue, the work of tongue and nose and skin has not yet been discovered, not yet been used widely. Maybe if it is discovered also, it is not being used widely. So we take input as a video, a picture, motion. We take input through the microphone. We take input by using the mouse click. We take the input through keyboard for data input. No? And when this input goes to the CPU, the processing takes place and we get output. The same manner, the other side, when this vision, the five senses, they take input in the brain, then the processing takes place. The object will think, react, no, and find out what is their action going to be immediately after receiving the input. Okay, so objects, they respond, they react based on the input that they receive from all the five senses. So on the basis of the message that they are getting, on the basis of input that they are getting, they respond, they react, and the processing takes place in the mind. They think is good or bad. They react to the situation. They react to the things that they see. They react to the taste that they get. They react to the smell that they get. Like wild animals, when they get the smell of the food that they are going to get nearby the rabbits or something can hunt. So their reaction is different. They become violent. They start looking for them. They sniff. No? So the reaction, the behavior will change. The behavioral pattern will change. And the behavior depends totally on the input message that they are getting to the input units. It means that some kind of unknown codes are getting executed in their brain, whether it's living being or non-living or the machine, computer, both the places some kind of codes are executed to get the output. The same manner here in the living beings or living objects, some kind of unknown codes are getting executed in their brain related to their behavior. So how they have to respond, how they have to act, the codes gets executed as soon as they get the message from the input senses. So now we move on to, now I hope this is clear. Now we move on to the stages of programming. Now this process of taking input, the thinking, analyzing and changing the behavior has been put down by human being in writing in simple plain English, that is called algorithm. So algorithm is nothing but the way of expressing the steps we think for solving a problem right from the moment inputs are received in our brain up till we complete the task. So all the steps when we describe one by one, giving their sequence, step 1, step 2, step 3, step 4, it becomes an algorithm, which is a kind of a program that has been processed by our brain right from the moment taking input, processing and producing the output, finally producing the output. Now the examples of algorithm that goes in our mind, some of the algorithms, some of the programs they executed in our brain unknowingly, that we decide, some works we decide, some decisions we take, some actions we perform. Any action that we perform, anything that we decide, some kind of unknown codes are getting executed in our brain, because our brain itself is not less than any of the supercomputers in the world, which is made by God. It is very powerful. It can work much efficiently. No? So let's see the example. Describing the way we reach home. Number one example is, suppose if you describe your friend how he can reach your home, though he's coming from far away, he's coming to home for the first time, you write a letter, you describe him, or you get in the plane from here, you land in this airport, you take a taxi, reach to this town or city, then from there you take this particular direction or this road. Describe all the steps one by one in sequence right up to your doorsteps. That description itself is an algorithm. The second example, describing the way to cross a busy street. Now how do we describe how to cross a road? We have been teaching the children how to cross the road, isn't it? So when we describe the steps to cross a busy street, that itself is an algorithm. The work is stand on one side, look left, look right, see when no vehicles coming, cross the road through zebra crossing safely, isn't it? So these steps, when we write down in the steps, these are this called algorithm. Third example, describing a recipe. Yes, we see so many recipes, the different kinds of foods, the food show on the TV and all. Now what they do, actually they describe the steps how the food can be cooked, right from the using the ingredients which are uncooked to mix them up, to cook them up, and go with the decision, go with the timing, go with the process, and finally get a ready-made uh, food which is already gets cooked and ready for eating. Okay, so describing a recipe is also an algorithm. We see in the recipe book, recipes are described, and that is a kind of an algorithm. Describing, preparing a cup of tea, how you prepare a cup of tea, when you describe it in writing in the paper, step by step in simple English, it is an algorithm. Describing daily morning job, what we do daily morning, as soon as we get up, open our eyes in the morning, what we do, what all actions we do, till maybe till we get the breakfast, we finish our breakfast, or till we get ready, or till we reach the office. When you describe all these actions, your actions step by step, it becomes an algorithm. Okay, and even arranging a school timetable. Okay, describing the process how you arrange your daily timetable, how you follow. Though we are arranging the books, looking at the routine, looking at the timetable, but we never know, we have never realized a kind of a decision making, a kind of a if then else, no, a kind of a complicated comparison is going on within our brain. No, a kind of program is getting executed in our brain, which is telling us either do this or do that. Take the book, keep in your bag, or keep it aside. No, so this decision of doing this or that has been purely controlled by the system in our brain. And in a similar manner, the programs are also developed using if then else. So ideas have been developed or derived from the same human approach, and we have seen so many objects they behave in different ways now depending on the different inputs, no, so these all are in their brain also some kind of unknown codes are getting executed. We don't understand the language, we don't understand what they are thinking, but looking at them we surely understand that they are getting some input, their brain is processing and they are acting according to the input that is coming to their brain. Okay, so in the same principle the computer also works. It also receives input or takes the input, process it, and give the output. The difference is that objects, the living objects are living. We are not controlled by electricity and all. But the computer is a machine that is getting controlled by the power, the electricity, no, or the battery that works in the battery. That we can use it whenever we want. We can shut down whenever we don't want. So, or whenever we want to work, we use it. Whenever we don't want, we shut it off. So, this is the similarity between, there are some similarities between the object's behavior or taking input working on IPO and the system that is working on IPO, the computer system that is working on IPO. So, similarity is there. Only difference is that how they take input and how they process and how they give output. In the computer, output is coming through monitor, but in the real world, the outputs are coming in the form of the behavior of the objects, how they respond by showing certain actions, certain behaviors, the physical behaviors. That is their output. For example, you see a dog, a puppy at home. When you come home, it will be happily jumping over you, over your body. It will be barking, and the barking is not wild, it is lovely barking. But the same puppy, you see some unknown person coming to your home, the input is different and the response is going to be violent. I hope you have noticed this. So when you start barking, you realize that yes, somebody unknown person has come to your doorstep. So you understand by the way the dog is barking, the puppy is barking. Okay. So inputs matter. How inputs are given and how the inputs are responding or working on the process of thinking and process of the behavior, how the behavior is getting changed by the input that it is coming to their eyes as they are seeing or they are smelling or as they are hearing or listening through the ears. No, so this is how the things are found to be same. Now when we write algorithm, when you're talking about algorithm, when you're writing algorithm, we write each and every single step in simple English. And this algorithm writing depends on the person to person. Okay. Now you write, you give one problem to 20 people or 100 people. Like for example, you tell them that okay, you write an algorithm describing your daily morning job. There will be different people doing different things. Some will be getting up in the morning after going to the wash and all. Some will be doing exercise. Some will be doing aerobics. Some will be going for dancing. Some will do yoga. It's different, no? And some people prefer to take shower before. Some people prefer to take shower after. No, some people will have a bed tea, then they go to wash. Some people will prefer to have brush, shower, and then they go for tea or take the breakfast. So it depends on the behavior, and accordingly, the algorithm description is going to be totally different for all 20 people or 30 people or 40 people or 100 people that you're giving. Hardly one or two will be same, but majority will be different because all different people are thinking in a different way. Their action, the course of action is different, so it is going to be different. And it's not only for human being, it's for all the creatures on the earth. They they behave differently, their way of working in different pattern, and this all depends on the codes that is there executing in their brain, which is unknown to us, which is unknown to any of the computer expert. No, but broadly we understand that something is going on related with input processing and output. Now when you see somewhere, when you go around in the park, somewhere you see a beautiful nest, bird nest. Now this bird nest has been created by bird only, simple bird, isn't it? But these birds are so expert. When you look at the nest, you'll understand that you'll surely surprised to see that beautifully designed, beautifully woven, no, beautifully, nicely knitting has been done for each and every string of the twigs, and it looks beautiful. And it's very difficult to say that oh, if the same thing is given to human being and you make it like this, it's going to be difficult for us. Why? Because their brain works in a different way. Their body, the physics has been made in such a way that they can respond, they can process data of their mind in a different way. So they can build this kind of things. But the basic working system in the brain also is same as what we have derived from their nature into the computer. For example, you see input, and in the work of processing, what works are carried out during processing? We calculate, we search, we sort, we repeat, we manipulate data, and we display. And then after displaying, either we store one part or we display it and then finish up. The same thing takes place here also. They also calculate, they also are very intelligent, they also think, they calculate, they choose a place. safest place they find for their nest, and they calculate. Then they start searching. What they search? They search for the twigs and straws and things that they can use for making nest. They choose the best one. They do sorting. Which one will go where? They will do sorting. They repeat the task from top to bottom or bottom to top to very fine way, very systematic way. They repeat the task of weaving it, no, knitting it one by one with the string, one by one with the grass, the dry grass, the twigs or dry leaves or whatever, and they repeat the task, and then they manipulate wherever they find something is problematic. You realize that, you see that carefully. They'll be taking out something which is not fitting. They again do the work, they repair it, and then finally we find their nest is ready, which is absolutely beautiful, and it is masterpiece in the nature. Okay. Now, other side we see the hunting animals. They also survive on the food. How they do? How they search the food? There are many animals. They search food by sniffing. They smell. They smell the food. There's some animal they taste and they find out. There's some animals they follow the trails of their food on the land, on the sands. No? And this is how they search their food, and then finally they get their food and they can survive. In the process of searching food, in the process of hunting for the food, or in the process of even sharing the food, or living the life together in the group, like elephants, no? They live in a group. How they live? Because they also communicate. They also have the family system like human being. No? So this all things have been closely connected with the world of programming, because we have taken 99% of ideas from the nature, and that's why what has been found out is really superb, really superb, and analyzed very well, that how the programming system has been developed to make us work or help us to do work in the computer. Now, this is how we can say that I can conclude that software object that we use in computer, that we create in computer, the programs that we make in computer, all are inspired, derived from those unknown codes which executes in somewhere in living beings, the brain of the living beings, which we don't understand, which we don't see, but there are some codes. We can see their behavior, we can see their work, we can see how they are taking input and how they are performing their behavior. We can observe and we can understand the whole nature is around the input, processing, and output, which is the key element, which is the main principle of working of a computer. Okay, so I hope it is clear to you. I hope it makes sense. You understood well how the concept of algorithm has been derived, how the concept of input processing and output has come. Next video we'll discuss about the other aspects of the programming, which is about the flowchart and pseudocode and then dry run and coding and dry run, debugging, execution of program and getting outputs. Now all these things we'll be discussing in the next video. Till then, keep watching. Take care. Follow my channel Java at Schools. You like it? You click on like, share, subscribe and enjoy my videos. Okay? Bye bye. Thank you.